I'd like you to think of memory as a series of lockers. There's a lot in common with lockers and memory, and I'm going to go over kind of the key points right now for this metaphor. One, lockers are numbered. It helps you figure out which locker to go to, just like memory is actually numbered. We call them addresses when they're numbered in memory. Also, there's this effort with a locker for trying to put something in it. It's not as simple as seeing what's in there and just kind of throwing it in there. You physically have to open the locker and then put something in and then close it back again, right? Writing is harder than reading. With reading, it's much more like this, just kind of taking the data out. We didn't have to spend all that time to put the data in. Now, also, like lockers, it's about access. Some lockers you just simply don't have access to. Some memory you just don't have access to. Like lockers, memory also has a fixed size. You can only put certain amounts of information in each locker. To do so otherwise would, well, it just wouldn't work. So how do we then deal with larger amounts of data? Well, there's this neat little trick you can do with memory, which is to distribute something over multiple lockers. Now, if we were to store something in 4 and 2 and then in 6, we'd have to go through that effort of opening and closing each one of them. However, we could do this and just say 7 and have that refer to locker 7. I'll remove this and put this in locker 4. And now, because I've stored a pointer to this first starting locker, I can take advantage of the fact that computers are so good at dealing with contiguous locker space and just start at 7 and walk through. Using this trick, we're going to now store incredibly complex data with a more realistic example now.